Sample problem. Two identical light bulbs, each with resistance of 2 ohms, are connected to a source with EMF of 8 volts and negligible internal resistance. Find the current through each bulb and the power delivered to each bulb and to the entire network if the bulbs are connected in A series and B in parallel connection. We refer to the figures below. For letter A. First we consider the series connection. To solve for the current in each bulb and total in series connection, we examine its properties. For series connection, the current in each device would be the same. To solve for the current, we solve the total resistance and we use equation 1. The current equivalent is then obtained using Ohm's law and we see that the current is 2 amperes. Next we determine the power delivered to each bulb and to the entire network of the bulbs. Recall the expression for the power by using equation 8. We see that the equivalent power is 16 watts as shown in equation A. To determine the power delivered in each resistor, we use the equation 9. We see that the power on resistor 1 and 2 are the same and they are 8 watts as shown in equation B and C. For letter B, we consider the parallel connection. Since the circuit is in a parallel connection, then the voltages are the same for each resistor and it is 8 volts. We then use this voltage value to determine the individual currents. By applying Ohm's law, we have the currents for each resistor to be 4 amperes as shown in equation D and E. The total or equivalent current is done by using equation 6 and we see that it is the sum of the individual current and it is 8 amperes. Next we determine the power delivered to each bulb and to the entire network of the bulbs. Recall the expression for the power by using the equation 8. It gives us a value of 64 watts. To determine the power delivered in each resistor, we use equation 9 and we have for resistor 1 and 2 to be 32 watts as shown in equation F and G. Comparing the two types of connection, it appears that the current values are higher in the parallel connection. The power is also higher in the parallel connection. This tells us that the rate loss will be higher or the battery will be drained much quicker in parallel connection. When buying electronic devices, if you wish to reduce cost, you would prefer appliances that have lower wattage.